Hello again. In this lesson we're going to talk about using variables in Visual Basic, what they are, how to declare them. I'll explain what data types are and how they fit into the picture, and then how to convert values from one data type into another and so on. Then we're going to talk about the difference between statements and expressions and look at different types of each. So let's go ahead and get started right now. We'll start by talking about one of the building blocks of code, which are variables. If you remember back to high school algebra, you might remember a math problem that looks something like this. X equals 3, y equals x plus 7. So what does y equal? Now in this problem there are two variables. There's x and there's y. And we can easily see that because x equals 3, that y should equal 10. At their essence, these variables simply represent some value. They are buckets that contain a value. In computer terms, a variable is a space in the computer's memory where it stores a value. And we as programmers can reference the value in the computer's memory by using a name that we give to that particular value called a variable. Also in algebra, we worked with only numerical values, but variables in programming languages can contain strings or dates or big numbers or small numbers and a lot more. So in order to know how big or small to make the bucket in the computer's memory, we have to declare a variable and tell the computer what type of information we plan to put into that variable. So I've taken the liberty of creating Lesson4, which is just a simple Windows Forms application, and you can see that I've already placed two text boxes, a button, and a label onto my Forms Designer surface, and I left their names the default, didn't change any properties, but we are going to start writing some code under the button one click event. So I double click the button and I'm just going to paste in some code that I have already typed up a few moments ago. Okay, so let's talk about these three lines of code. Obviously line 5 is a code comment where we can type any free-form information we want to remind us what this section of code does. Line number 6 is dim my string variable as string. And this is a very typical variable declaration. Variable declarations must start with the keyword in Visual Basic, dim, D-I-M. And this will tell the computer's memory that we are about to put something inside of it called my string variable, and it will hold string values. And we'll talk about strings in just a moment. Also, we have another example of a variable declaration in line 7. Dim my initialized string variable as string equal to Bob in quotation marks. Okay, so during the declaration we can also initialize its value. Initialization means that we take two steps in one line of code, both declaring the variable and setting up its space in memory. And then the second step is setting its value immediately. So we define how big the bucket is, and then we immediately fill up the bucket with something. In this case, the string literal of Bob. Also notice that the myString variable has a little green squiggly line underneath of it. This is to let you know that we've declared a variable, however we've never used it within our code. So while this is not a problem, it's just a friendly reminder that you've created a variable that you never really used. So let's move on. I'm going to paste some more code in. And as you can see in these first two lines, in lines 6 and 7 that we created just a moment ago, we created two variables. Each of their types are strings. So you can see that we use the as keyword and then the variable type, which is string. But also we can create different types of variables that are numeric in nature. Strings can contain alphanumeric characters, both numbers and letters. However, if we need variables that can be used for mathematical equations, then we would need to use one of the several numeric data types that are available, such as an integer, which can contain values from negative 2,147,000,000 to a positive 2,147,000,000. We can use the double, which as you can see is a very large number. Also, the thing about the double is that it allows us to include decimal places. Or we can use what's called a Boolean, which is a 0 or a 1, a yes or no. So you would use these whenever you're trying to evaluate whether something is true or false. And there are a lot of other data types that are available, but these four will help you get a long way as you're first starting out. So just one or two little gotchas before we move on. In Visual Basic, you have to use the proper spelling everywhere you reference a variable, obviously. You can't misspell variable names throughout your code. But your use of capital or lowercase letters doesn't matter, and that's different than other programming languages like C#, for example. So if you were to have my integer, where the I in integer is a capital letter, and you have another variable in your application called my integer with a lowercase I, these are essentially the same variable. There's no difference between these. Again, unlike other programming languages where it would treat these two variables as two separate, distinct, different variables. The two lines of code are exactly the same. In fact, in Visual Basic 2005, the code editor will correct the capitalization to remove any confusion that you might have based on the capitalization of what you dimensioned the variable to be originally. Okay, so let's also take a moment to talk about strings. Whenever we type in a string, like we did in the Hello World application, we used quotation marks around the text. And we also used quotation marks just a moment ago when we initialized our string variable equal to Bob. Now, why do we do that? Well, it's really simple. It helps the VB compiler distinguish between what's called a string literal versus a variable name. Now, here's one way to make that distinction. The variable is a bucket, and the string literal is what goes into the bucket. A string literal could be a message that we want to display to the user. It could be values that we want to save into a file or in a database, or it could contain a file location on your hard drive or any text that has meaning within our application. So let's take a look at another little example here. Okay, so I'm going to paste in some more code here, and let's take a look at example 1C. Okay, we have in line 17, dim hello as string. Is hello, in this case, a variable or string literal? It is a variable because we have used the dim keyword and the as keyword, and we have told Visual Basic that we want to create essentially a new variable that has a string data type. In the next line of code, line number 18, we are setting that variable equal to the value hello world. A little misspelling there. Hello world. In line 19, we have a message box.show hello. Now in this case, in line number 19, is the word hello a string literal, or are we referring to our variable? We are obviously referring to our variable hello. But in line 20, what are we doing? We are using a string literal because of the use of the quotation marks. And so we will display the word hello in the message box. So hopefully that helps you see the distinction between a variable name and a string literal. Again, the easiest way to remember it is that the variable is a bucket. It's something that stores value. It is not a value in and of itself. By default, whenever you declare a string in this way, it is initialized to an empty string, like so. A string literal, however, is the value. It is something that you would place into a bucket. And so just keep that distinction in your mind because it'll come in handy as you're getting started. Okay, so we've spent several moments now talking about variables, but why would you use a variable in the first place? What is the purpose of a variable? Well, simply put, its purpose is to save some value off until you're ready to use it, or you're ready to refer to it, you're ready to compare it to something else, you're ready to evaluate it against something else. There might be a dozen different reasons. At this point, let's do another simple example. It might help make more sense. Okay, so here we have example 2. So in line number 23, we have dim first text box as string equals textbox1.text. So what have we done in line 23? We have dimensioned a new variable called first text box. we set its type equal to string, and then we initialize the variable to contain the value that's in our textbox1.text property. Now you recall from whenever we originally built this application that we have two text boxes. This one is text box 1, this one's text box 2. Okay, so what we're going to do is take the value from text box 1 and place it into a variable called first text box. We do essentially the same thing in line 24, where we dimension second text box a string equal to text box 2.text. Now this is where we are starting to talk about the use of variables. And admittedly, this is a very simple example, so the true meaning may not come out here. You might still not have this question answered in your mind. However, you can see in line 26 what I'm able to do now with the value I've retrieved from the first text box and the value that I've retrieved from the second text box. I'm able to concatenate those together and put a space in between them and set that value, that expression, equal to label1.text, which is another control that's on our form. So I'm able to take the value out of a text box, which is input by our user. I'm able to work with it, to manipulate it, to change it in some way, and then combine it together with other variables that are stored within my application. And again, very simple example. This may not help you conceptualize it completely, but let's use this as a working definition and continue on. Okay, so now that we've talked about the purpose of a variable, let's move on to a slightly more complex case. To paraphrase something that I said a little bit earlier, whenever you declare a variable, you're creating a space in memory that can hold a value of a certain data type. Some data types require more space in your computer's memory than other data types do. So what happens if you try to put a value into a variable that's already been declared as one data type, but the value that you're trying to put into that variable is the wrong data type? What's going to happen? Well, the answer is not so simple. Now, in some cases, the value will be what's called implicitly converted to the correct data type, which simply means that the Visual Basic compiler will perform the conversion for you, and you really don't have to think about it. So here is an example of an implicit conversion. Okay, we have my value as integer in line number 30, and then in line number 31, dim my other value as double equals 3.14. And then we set my value equals to my other value. So let's do this, messagebox.show, and then we'll do something like my value. Okay. Now, whether you realize it or not, I have basically done two implicit conversions here. Where's the first implicit conversion? In line 32, where I am taking a double, which, as you know, can be a larger value. It can store quite a bit more information than an integer can, which means that we can pack so many numbers into that when we go to convert it to an integer, it simply won't fit into that spot in the computer's memory. And we can also put values after the decimal point. In this case, I've set my other value, initialized it to 3.14. Now, what will happen whenever we try to do this implicit conversion? What will the Visual Basic compiler